Right, so what we're going to cover today is description of transistor based circuits, okay? So descriptive questions on transistors. Now, essentially, what we're looking for is for you to demonstrate that you recognise the purpose and function of like what this type of circuit is for. Right. So when you see a circuit that looks like that, if you're doing National 4 assignments, guys, if you're doing National 4 assessments, just keep doing them. This is for the people that are try to get the National 5. Right, okay, so the idea when you look at a circuit is, do you understand what's going on here? So when you look at that circuit, what you should be doing is, hopefully you recognise that this arrangement on the left-hand side here, that's a voltage divider that's populated with two components that make it a sensor. And that guy down there is a thermistor. It responds to changes in temperature. And it's on the bottom half of the sensor. So that sensor is acting as a cold sensor. So this is a cold sensor. This device here is a heating element. The output device is a heating element. So the idea is the heating element is going to come on when it's cold. So at its most basic, the hope that when you see a circuit like that is you can identify what it does, what's its function. So when you're describing the operation of this circuit, you want an overall heating element comes on when it's cold, because this is a cold sensor. You're going to need more detail than that. You're going to need to go through that process of describing the operation of the input sensor. When temperature goes down, the resistance of the thermistor goes up, making sure you get those the opposite way around. Those arrows always are the opposite way around when you're dealing with thermistors or LDRs, like dependent resistors. As the resistance of the thermistor goes up, the voltage across the thermistor goes up. And in this case, the voltage across the thermistor and V out of the sensor are exactly the same. So as voltage across the thermistor goes up, V out of the sensor also goes up. So you're going to need to make sure you get that descriptive part of the sensor into these types of questions. As temp goes down, resistance of the thermistor goes up. As the resistance of the thermistor goes up, voltage across the thermistor also goes up. As voltage across the thermistor goes up, V out of the sensor goes up. You two need to stop chatting. So that's that descriptive part of the sensor. So that bit there is describing the input. You've then got as sensor V out goes up, transistor approaches saturation. Saturation is that word that we use to describe it when a transistor is all the way on. when transistor saturates, the heating element will heat up. So that's then describing the kind of process and output. Now, there's a couple of things missing from it. In your descriptions, when you do this in an exam, do not abbreviate. So I've written RTH there. You wouldn't do that. You'd write resistance of the thermistor. And so on and so forth. The other thing you need to do is ensure that you name every component. So in the description that I've given so far, describing the operation of the input, the process and output, I haven't mentioned the variable resistor. And I haven't mentioned that resistor in the middle there. I know you're taking a photograph of that, but obviously I'm going to make this video available to you. So you will have a digital record of it. You know what I mean? Just in case you didn't know that. So you need to name every component, but you also need to ensure that you state the function of every component. So, things that are missing from this so far are the variable resistor allows the user to control the sensitivity of the sensor. The base protection resistor protects the transistor from too much current on the base. And then the last thing I'm going to put in, just for good measure, the transistor acts as a switch. You alright, Grimson? Something you can't read? Sorry, a wee bit louder, I can't hear. The green writing. So the green writing are 3 bullet points. The first one says the variable resistor allows the user to control the sensitivity of the sensor. The next one now says the base protection resistor protects the transistor from too much current on the base. And then the last one says the transistor acts as a switch. You know, it's possible that you would see circuits that looked a bit more complex than that and had more stuff in them. So here's another example. Now it's still based on the same knowledge though. So what we've got here is, guys, you two need to stop chatting. So what we've got here is another transistor-based circuit, and you can see the topography is essentially the same, but it's got this on it. So again, as it was in the last one, you should be able to kind of identify an overall, what is this thing going to do, right? Can you do that for me right now? Can you identify what's, you know, the overall, what's going to happen in one bullet point? So you're looking at the sensor type, trying to identify what that sensor's doing, and then looking at the output. So can you identify that? Anybody want to stick their head above the parapet and take a guess? What kind of sensor is it, Ben?
A light sensor.
It is a light sensor, that's correct. What about the output devices? It should be the easy bit. What are the output devices? Yes. And a light emitting diode. No, don't abbreviate when we're talking about this stuff. So the motor and the light emitting diode are going to come on when conditions are light. Can anybody tell me what's missing from that circuit? Something really important missing from that circuit. Oh, a couple of people know. What's missing?
The diode.
What for?
The relay.
Yeah. Right, so this dotted box is drawn around a relay, a single pole, single throw relay. That's an electromagnetic device. That electromagnetic device, when it's powered off, could very well destroy that transistor. So, it should have just a normal signal diode in there. So there's a wee component missing from it. If you've got a relay, a motor or a solenoid in that position, you need to put a diode across it. So there's a statement there. We then want to go through the same process about the sensor. So in this case it's, hold on, let me move it over a wee bit. So as light level goes up, the resistance of the thermistor goes down. They two are always the opposite way from each other. As the resistance of the thermistor goes down, the voltage, I've said thermistor, but it's an LDR. Goodness sake, Di-Nardo. What's the matter with you? This is the voltage across the LDR. And that's the resistance of the LDR. So as the voltage of the LDR goes down, and this time, the output voltage of the sensor will go up this time because it cut Kirchhoff's law. So again, you need to get that description in. As, and remember, you don't abbreviate in the exam, as light level goes up, the resistance of the LDR, you would write resistance of the light dependent resistor, goes down. This is now the third time I've asked you to stop chatting. One more time and I'm going to remove one of you from the room. As the resistance of the LDR goes down, the voltage across the LDR also goes down. As the voltage across the LDR goes down, V out of the sensor must in this case be going up. So that description of the input sensor essentially describes the operation of that thing as a light sensor. When light level is high, V out is high. It's a light sensor. You then move on to describe that kind of switching process. So as V out of the sensor goes up, transistor approaches saturation. Sorry, I missed this out for the last one. At 0.7 volts. Probably really important that you include your knowledge of that magic number in this description. Right? When transistor saturates, it switches on. And the relay energizes. When the relay energizes, the motor and LED light emitting diode switch on. So you've successfully traced your way from a changing light level to this guy coming on. You've explained the kind of function of it, but again, what's missing are these statements about some of the components. So you would have to state explicitly the variable resistor. Allows the user to set the sensitivity of the sensor. The base protection. Now, you obviously you want to be responsive to the question. So I'm just going to make a wee addition here. This doesn't mess anybody up completely. I'm going to give that a name, RB. So you'd be responsive in the question. RB protects the transistor from too much current on the base. That's why it's called RB, resistor on the base. I don't need to put in the transistor acts as a switch, because I've already said it here. When the transistor saturates, it switches on. I've already indicated that it acts as a switch in my description, so I don't need to say it explicitly. The diode, let's talk about this diode here. Protects the transistor. Loads of people get this bit wrong. They think it protects the relay. The diode protects the transistor from back EMF generated by the relay. And why are we using a relay? The relay allows a low power circuit to control a high power circuit. So this last point about the relay, that's the old, depending on what this system is used for, we've already talked about a user adjusting this guy over here, that variable resistor. So you don't really want that variable resistor to be part of a circuit that's got high voltages and high energy in it, in case the person gets hurt by that. So you keep this side of the circuit low energy to keep the person safe, but, and I suppose to make it more efficient, but what if you need the motor to be, really powerful? So this is why you need to be able to have the facility for a low voltage circuit to control, or a low energy circuit to control a high energy circuit. So that this side is safe where people are messing about with it, but the output side is powerful and effective. And that's what the relay allows you to do. Notice that the low energy circuit on the left hand side is, it's not connected electrically to the high energy circuit. They're what we call, they're isolated from each other. Isolated is a word that we use in electronics and electrical theory to talk about two things that are not connected to each other. That dotted line is the only connection between those two circuits, and that little dotted line in there represents magnetism. That really is an electromagnetic device. Yeah, where am I? No. What's going on here? I don't know what's going on. Right, but either way, so that's a full description of this thing. So yeah, I just wanted to talk about, you know, that difference there. Oh, geez, oh, what's going on? My software's going spare. So I just wanted to talk about what that relay was for, what that diode was for. That was the kind of big difference there. Pause this. Can I pause that? Where's my... Yes, I just wanted to draw attention to the fact that these two circuits are isolated from each other. A common mistake is that people would connect that 6-volt supply line to that 230-volt supply line. They should not be connected to each other. Right, okay, there's another wee thing that I just want to talk about. Just in case anybody does make this mistake, I want to talk about the importance of getting these arrows the right way round. The relationship between light level and the resistance of the LDR is always going to be the opposite way round, and that's the same in this one. The two arrows are always going to be the opposite way round. When you're talking about the resistance of a component and the voltage across it, so the purple one and the blue one, those two arrows will always be the same way round. If resistance goes up, then the voltage goes up. You see there, resistance for the LDR is dropping, the voltage across the LDR is dropping. So those two are always the opposite way around. These two are always the same way round. It then gets a bit shady after that because it depends. I've just realised that I haven't actually put that in there as voltage of the LDR goes down. The sensor goes up. So notice those two arrows are the opposite way round because they're two different voltages. And Kirchhoff's second law states that those two voltages must add up to Vs. So if VLDR is going down, Vout must be going up to account for the difference. Whereas in this circuit, those two arrows are going the same way because they are the same voltage. The difference is the transducer is on the bottom half of the potential divider in this circuit, whereas in this circuit the transducer is on the top half. Transducer being the device that's detecting the change in energy. That's it. That's describing the operation of these circuits. I'm going to put another one up on the board, and I'm going to ask you to complete a full description of it, okay? Yeah. Yeah. So I've made a slight change to it, get it a wee bit harder. The only change I've made to it is, yeah, oh come on. The only change I've made to it is that I'm using a single pole double throw. So there's two output devices. So before you start talking, let me just draw your attention to something. The relay coil can only be one of two states. Okay? So that means that at all points, one of these two devices is going to be on. So rather than like the motor, you know, the circuit having an output or having zero output, this is always going to have an output. The only difference is the output changes over between two things. You get them in the right way. The relay is shown in its rest state. The relay is showing, that switch is showing as if the relay is off. Okay? Give it a shot. We've got those two other examples. What I'm going to do is I'm going to stop this video now and save it and put it up on a team.